Minds in physics have been on this epic hunt, chasing a single, beautiful theory to explain, well, everything. But what if they were looking in completely the wrong place? Today, we're diving into a radical new way of thinking that's changing the very game of scientific discovery. Okay, let's get into it.
Okay, so what you're looking at right here, it's basically a roadmap of a scientific revolution. On one side, you have the old dream, that one single all-encompassing answer, and on the other, a totally new, more practical approach that's actually leading to real breakthroughs. We're going to follow this map and see exactly how we got from chasing everything to building something.
So, for generations, right, the absolute holy grail of physics was this idea of a single, elegant theory that could explain it all. Just imagine, one equation describing both the cosmic dance of galaxies and the tiniest flicker of a subatomic particle. I mean, the appeal was just huge.
So what exactly was this grand prize? Well, they called it the theory of everything, or TOE. The whole idea was to find this one master equation that could finally unite the two massive pillars of modern physics: quantum mechanics, the wild science of the very, very small, and general relativity, the science of the very, very large. It was supposed to be the final achievement of science.
But, after just decades of hitting wall after wall, this little nagging question started to bubble up. And it was a big one. What if we've been chasing a ghost this whole time? What if the goal isn't one single answer for everything?
And that question, well, it leads us right to the new hero of our story. And it's not a theory of everything, but a theory of something. And this isn't just, a cute name change. It's a fundamental shift in strategy, one that was born from decades of really hard-won wisdom. This slide just lays it out perfectly. We're moving from a quest for totality, which is like this one giant all-or-nothing mountain we have to climb, to something more like a whole mountain range. Instead of trying to conquer the absolute highest peak in one go, scientists are now focused on summiting individual peaks, one at a time, and then figuring out how they all connect.
So, let's jump into our first bounded reality, quantum gravity. Instead of trying to solve the entire cosmic puzzle at once, scientists are asking these really specific, testable questions. Like, can we actually find the ancient echoes of the Big Bang, the so-called primordial B mode, in the faint light of the early universe? Can we measure the super faint radiation that's supposed to leak from black holes? See? These are problems we can actually tackle and get real clues from.
Next up, we've got the great cosmic mystery, the dark sector. Now, the theory of something doesn't see this as just some big, unknowable void. It's another solvable puzzle. We can build these incredibly sensitive detectors deep underground to literally hunt for elusive dark matter particles. We can use our most powerful telescopes to map the universe's expansion to get a handle on that weird force we call dark energy. It's a targeted hunt for the universe's missing ingredients.
And you can see this exact same approach in high-energy physics. I mean, we're using our most powerful particle colliders with really precise, measurable goals. Can we find any new particles that go beyond our current, standard model of physics? Can we study the famous Higgs boson with enough precision to see if it's hiding any new secrets? Every single experiment gives us another solid piece of that puzzle.
Okay, so how does this new approach actually work in practice? What are the new rules of the game? Well, it's all guided by three really powerful principles, a whole new philosophy for doing science at the very edge of what we know.
And here they are. First up, clear falsifiability. This is crucial. It means every idea has to be testable. If you can't even imagine a way to prove it wrong, it's not really science. Second, a convergent approach. We use a bunch of different methods to attack a problem. And for it to be true, the answers have to line up. And third, maybe my favorite, epistemic humility. We have to accept that we might not have all the answers, and that's okay. It's about being honest about what we don't know. So you see how these three principles work together? Kind of like a well-oiled machine. They keep the science grounded and rigorous, they stop it from just becoming a bunch of disconnected facts, and they maintain that absolutely crucial sense of honesty about the limits of our knowledge.
Hey, can I just jump in for a quick sec? If you're enjoying this journey to the frontiers of science and you want more explainers that break down these kinds of huge ideas, please take a second to hit that subscribe button. And hey, let us know in the comments what you think about this whole shift in physics, and share this with anyone you know who loves a good mind-bending topic. It really, really helps us out. Now, look. Any big new idea is going to have its doubters, and that's a good thing. So let's actually take a look at the toughest questions the critics have thrown at this new approach, because understanding the answers is essential to seeing why this change is so powerful.
All right, the first major critique is this one. Have we just given up on the big picture?
Are we just collecting data for the sake of it, like stamp collecting, instead of trying to understand the nature of reality? Has theory been abandoned in favor of just crunching numbers?
And the answer is a hard no, absolutely not. This is not random data collection. The thing is, theory is still the guiding light. It's what tells us where to look and what to look for. The experiments inside each of these bounded realities are super targeted, guided by our best theoretical ideas. It's like having a treasure map for the universe.
Okay, but what about the second big question, the one about fragmentation? If we're only looking at these little pieces of the puzzle, don't we risk losing sight of the whole thing? Doesn't science just become a bunch of disconnected niche fields where nobody's talking to each other anymore?
But this is where that second principle, the convergent approach, is just so important. The goal, explicitly, is cross-domain consistency. It means the results from quantum gravity have to make sense with the results from high-energy physics. The puzzle pieces are actually designed to fit together to create a larger, more consistent picture of how reality works.
And this leads to the final, and maybe the most personal critique. Is this whole thing just a retreat? A sign that physics has lost its nerve? Given up on its grandest dreams? Has it just lost its vision for the future?
But it's actually the exact opposite. This isn't a lack of vision. It's a smarter kind of vision. It's a pragmatic and realistic vision that's focused on making actual, real, verifiable progress. It's the vision of building a solid foundation of knowledge, one brick at a time, instead of chasing some beautiful but maybe unreachable castle in the sky.
So when you boil it all down, what's the big takeaway here? It's really about a new understanding of how science works best, by recognizing and even celebrating its own limits. There's a phrase that just perfectly nails the whole idea. The journey is from totality to integrated fragments, and the goal is understanding within our limits. Man, there is so much power and wisdom packed into that simple idea.
So let's be super clear. This is not a step backward. Not at all. It's an evolution in how we think scientifically. It's about building a reliable, robust map of reality, one verifiable piece at a time, creating a body of knowledge that we can actually stand on and build from.
And that leaves us with one last thought, one that goes way beyond physics. I mean, in our own lives, in our own work. What could we accomplish if we adopted this mindset? What kind of progress could we make if we focused less on finding some mythical, perfect solution for everything and more on mastering the complex, bounded realities right in front of us? It's definitely something to think about. Thanks for tuning in.
You know, for